Hello, in this lesson I want you to solve quadratic equations by graphing. Just like with systems of equations, when we solve quadratic equations, there are a number of different ways to solve those equations. So today in this lesson we're going to concentrate on graphing. You're going to come across something that is a double root. When we're in class, we'll probably do some mental math, but we won't do that online. So let's start with our key concept. When you graph a parabola, where it crosses the x-axis, your x-intercepts, notice you can have two of them, one of them, or no x-intercepts. Well, your x-intercepts, when we put it into an equation, they turn out to be the same value as the roots. So these are called the roots when we graph, when we solve an equation. So when you graph, you can have two answers, which, to tell you the truth, that's most of the time what we get. You can have one answer. That one answer is called a double root, because actually it's crossing it twice, but it's crossing at the same value twice. So we just say, we call that a double root. We just write it down once. If it doesn't cross the x-axis at all, then there is no solution. So that's why we say there's no solution when we graph it. Now you're going to have to graph these either by hand or with technology. I don't care if you use technology on the paper assignment. Alex is going to make you do it by hand by finding a table of values and your vertex. So let's start here with example 1. X squared minus 3x minus 10. We're going to write something called the related function. The related function means we're going to replace 0 with y. So I'm going to say y equals x squared minus 3x minus 10. So I've graphed that on Desmos. And like I said, we could do this by hand. And let me shrink this in here so we can see the graph. And notice it crosses at -2 and 5. So my answer is, I'm looking for x, remember. Y is 0. X equals -2 or 5. If you do this on Desmos, or not Desmos, on your Alex part of your assignment, the notation, they'll just go -2 comma 5 is what they'll have you type it in. I like to write x equals -2 or 5, or even x equals -2 or x equals 5. Now, on example 2, notice we have to do a little bit of work. And our work is, unlike example 1, it already equals 0. I can't write a related function for -9. So what I'm going to do is I want to make one side equal to 0. I would suggest that we add 9 to both sides because that seems the easier side to graph. So then I can say x squared plus 6x plus 9 equals 0. I will write my related function, y equals x squared plus 6x plus 9. Now, I've graphed that also. So let's take a look at the graph of that one. There is y equals 6x plus 9. X squared plus 6x plus 9. And notice when I look for my x-intercept, there's only one of them, -3. So my answer is x equals -3. I only have to write it down once. Now, you could write two related functions. Instead of adding 9 to both sides, I could write a related function for the left side. I could say, oh, my left side, y equals x squared plus 6x. I'll do y equals -9. So I've got a system of equations here, and I found out where they intersect. So if you want to see that, I've also graphed that here. Here's y equals x squared plus 6x. Here's y equals negative 9. Rather than looking for my x-intercepts, I look at where they cross. And lo and behold, they cross at negative 3 and negative 9. I'm interested in x equals negative 3. So you can do this either way. You could make it equal to 0, which is what I suggest, and then write your related function, graph that related function, see where the x-intercepts are. Or you could do the left side, the right side, and you can see where they intersect. But remember, we don't look for the x-intercepts, we look for the intersection of these two. One's going to be a parabola, one's going to be a line. So make sure you do the intersection here.